Hi, welcome to another video on malware. And in this video, I thought I would talk a bit about rootkits. And certainly if you have been interested in the anti-malware space or in malware in general, I'm sure you've heard the term rootkits. And what I'd like to do is begin by doing a bit of an introduction and overview. And then maybe in future videos, I can go into some more detail on how rootkits work. So for starters, what is a rootkit? A rootkit, the way I'll define it, is it's a set of software components that are geared towards maintaining persistent and undetectable presence on a computer. Okay, now what does that mean? Well, when you think about it, if you've got a software application running on your computer of any sort, there are certain things that that application will have that will kind of manifest or really announce its own presence. So what kinds of things can you tell in terms of software? So for example, if you have a software application running on your system, maybe there'll be a file or maybe a set of files associated with that software. Maybe there'll be directories that those files are located in. So these are already two signs that you can use to identify that a particular software application is on a system. Maybe if you double click that piece of software, it will then launch and it'll run, and so you may be able to find a process. And this, for example, is something that's running, and if you use Windows, you might find it using something like Task Manager on Windows, and that's a way for you to find a running process. And so a piece of software might manifest itself as a running process if you start running it or double click on it or execute it in any way. As part of that, you might have a process that uses up CPU. So you can see, for example, the CPU count. Maybe in the process of doing that, it'll take up some more disk space, or maybe it'll write some files, and so you may be able to just see general disk space usage going up as a result of the process running on your system. Another thing you might notice in relation to a process is that the process might create a registry key. So for example, let's say the process is an installer, that it's installing a new software application onto your system. And typically when you have a new software application, you will see a registry key associated with it. And this is kind of more Windows-centric, but that notion does exist. And what else can you possibly see? You might, for example, see a network access. So maybe that particular process is going out to the network to download something. And that'll manifest itself via the network. And so already you can see that one particular file on your system, one piece of software, in and of itself already has many different ways, and I've already listed just 7 ways here that it can manifest itself on the system and kind of be detected. And so the idea behind a rootkit is to find ways so that these different traces don't manifest themselves. In other words, it's hard to actually identify that this software exists on your system because these traces have somehow been hidden. And maybe the analogy to use here is, imagine there's a burglar in your house, and the burglar, what a burglar will typically do is they may break in at nighttime. They may camouflage themselves by wearing all black, and they'll put a ski mask on. And so if it's dark in your house, you will have a hard time seeing the burglar. The burglar is physically there in your house, but maybe the standard way of looking for the burglar by using your eyes might not work that well. You may need other techniques, like maybe you have to shine a flashlight at him, or maybe you can look for footprints, or you might hear glass breaking, something along those lines. But just trying to visually find the burglar will be very difficult because of the way they're dressed. And similar with the rootkit. Rootkits basically are able to hide many of their traces on a system, but that in and of itself may not be enough. You can still detect them, but you may need to use some other tools for detecting them. Now, I want to make another point about a rootkit, which is that rootkits, as a class, just something hiding itself, it's not inherently malicious. I mean, the idea is you might have a lot of situations in which you would want to purposefully hide files in a way that's okay. For example, a lot of enterprises, a lot of companies might wish to hide specific system files from users. Maybe those files are associated with doing backups on a system or general maintenance of the system. And they want to make sure that a typical user doesn't interfere with those files or tries to delete them by accident. And so just because something is a rootkit doesn't mean it's malicious. However, I would say that combination of kind of a rootkit plus malware, in other words, if you take a piece of malware and you apply rootkit techniques to it, or you have that malware hidden via a rootkit, that could really be bad. So that combination of rootkits plus malware could be really bad. Maybe I'll put really bad. But put two reallys, two really bad. But just a rootkit alone may not be bad. Okay, because you can have good uses for it. Now I want to talk briefly about the origins of rootkits, and then maybe in a future video I'll talk a bit more about how they work. The idea of a rootkit was actually came from the Linux, or actually Unix operating system, so really the origins are from Unix. And if anybody remembers the days of Unix, in Unix, people, you would often have a bunch of typical system utilities, things like, grep, which was a way to find words in a file, ls, which is a directory listing utility, login for logging in, password to change your password, netstat for getting data about the network, etc. And these were kind of common utilities. And the first rootkits were basically Trojanized versions of these utilities. So an attacker would come around and they would basically take these utilities and come up with bad versions of them. Bad versions of grep, and I'll mark it by writing them in red. Bad versions of ls and logging and so on and so forth. And so the idea is that if you the attacker would put these bad versions in certain places on the system and then hope that you would execute them. And if you would execute them, you might help the attacker gain some additional data, maybe elevate their privileges on the system. And really the attacker was interested at that time on a Unix system in getting what was called root access. And root is a term that's used in Linux, or in Unix actually, to identify the user with the most possible privileges. And in Windows, this is also known as an administrator, but in Unix it was called root. And in fact, in Windows, it's interesting, and most people end up running in an administrator role without thinking about it, but in Unix, that wasn't always the case. You would typically log in with a limited set of privileges, and the idea behind a rootkit was for an attacker to try to elevate that set of privileges. And in fact, I remember the first rootkit I encountered in the Unix sense. Actually, it was a friend of mine who put a Trojanized version of ls in his directory, and he would try to convince people to go and look at his files. And if you would go into his directory and type in ls, the hope was that you would run the Trojanized version of ls, which would then give him all sorts of privileges and allow him to see all sorts of stuff that you were doing on your system. So the idea was that he basically used this modified version, and because attackers named these things, gave these things the same names as the legitimate tools, like they used names like ls and grep and login, it was hard for a typical user to know that these were actually bad or rogue versions of these pieces of software unless they looked more deeply. So the idea was to kind of hide your traces just a little bit. Now, that's kind of the original version of a rootkit. Nowadays rootkits are much more broad. They tend to apply more to Windows, at least in the malware space, and they really are around more general purpose techniques and more sophisticated techniques that a piece of software can use to maintain its presence on a machine and to really hinder somebody from being able to detect that presence on the machine. Okay, so I'm going to stop right here, and in the next video I will talk a bit more about how rootkits work at a high level. I hope you join me for that. Thanks a lot.